Okay, this is Mr. Girk. Welcome to the vocab for geometry, chapter 4. This is the first part of the vocabulary for chapter 4. There will be two parts because there's so many words, and we're going to split into two. So here's the first one. First word we're going to talk about is a vector. All right, it's a quantity that has both direction and magnitude. Magnitude is a fancy word for size, and it's represented in the coordinate plane by an arrow drawn from um, one point to another. So in this right here, we have a vector. The vector, its name is PQ. P is the starting point. All right, fancy name for that they call it in the book is the initial point. And Q is the end point, and the fancy name for that is the terminal point. Um, we will go over in class how to show that, how it's labeled, but we read this as vector PQ. The vectors that we're going to use are to help us with types of transformations, and that's big on this chapter. This whole chapter is about transformations. And a transformation is a function that moves or changes a figure in some way to produce a new figure. So um, there's four main transformations that we're going to talk about. There is a translation, which is what we're going to do first. That is where you take your image and you slide it in a direction. All right, it can just move in any directions. That's a translation. Um, we also can do reflections. All right, we can take this star and we can reflect it over a line. All right, so we can have a reflection over a line here, and we'll just talk about that in just a second. But if we can take that line, we can take that star, we can reflect it over that line. All right, we can also do a dilation. All right, and that is let me get rid of that one, where you take the image and you can make it smaller or larger. All right, that's a dilation. Or we also have a rotation. All right, we can rotate that, turn it however we want, either direction. All right, so we can also rotate it um, around a point. We'll get into that more detailed later. All right, so we have an image and a pre-image that we're going to deal with these transformations. All right, image, a figure that results from the transformation of the geometric figure, and the pre-image is a geometric figure consisting of the inputs of the transformation. So the pre-image is what we're going to start with always, and the image is going to be the result from the start. So um, let's go back up to this star. All right, we'll bring it down here. So um, if we were to reflect this star, all right, flip it up and down, okay. And let's say we reflected it over this line right there. All right, this first one, all right, this would be our pre-image, okay. And the image that we reflected, so we reflected this star over the line here, and this is our image, our pre-image here. This became our image. Okay, so the pre-image is when you start with, image is the result from the transformation. So the first one we're going to talk today about is translation. Translation is a transformation that moves every point of a figure in the same distance at the same direction. All right, so if we go back up to vectors, we'll notice that a vector has a starting point and an ending point. All right, and it's got an arrow on the end. Okay, kind of like a ray. You get a starting point and an arrow that goes on. So what this represents is these vectors, all right, are going to represent the distance and the direction. So let's just say we've got our line segment here. So our line segment AB. And we're going to translate that line segment AB. All right, so we'll have a vector A going this direction and this distance, excuse me, point A going this direction and this distance along this vector. And we'll have vector B going the same exact direction and the same exact distance along this vector. And what that does is, if we do that, we are translating it. We are sliding it that direction. So we have a new image. All right, our pre-image is segment AB. Our new image is this segment, and this is called, let me get it, here we go. This new segment is called A prime. That apostrophe there, we say S prime. And the new point over here is B prime. So it is A prime, B prime. This segment is AB, pre-image. The new image is A prime, B prime. So that is a translation, is when this slides in the same distance and same direction, both points. All right. We also have a rigid motion. Excuse me 1 second. Okay, sorry, I had to step away there for a second. A rigid motion, a transformation that preserves the length and the angle measure. Okay, so rigid motion, it's important to know that the length of the segments or the angles of the shapes or polygons, they do not change. They're being preserved by a rigid motion. So if we look up here, this is an example of a rigid motion. All right, the length of our segment AB was preserved. It did not change. Okay, if we were to do the same with a right triangle here, for example, and we were to translate it over to here, the lengths of each side and the angles of each angle are being preserved. All right. Other types of them that work are when you reflect it. Other types of rigid motions are when you reflect it. Oops. Let me do this. Let me clone it first. All right, and let's say we were to reflect it. Okay, each segment was preserved and each angle measure was preserved. It's just now a reflection. So that is a rigid motion. Moving on. We have a composition of transformation. And with that, it's just a combination of two or more transformations, all right, to form a single transformation. So there's a nice little picture over here to the right. All right, so if we were to look at what the pre-image was, we would be able to tell by looking at the letters. All right, the green image has a S with 2 apostrophes and an R with 2 apostrophes. That would be called S double prime, R double prime. These have 1 apostrophe, S prime, R prime, and the blue segment has no apostrophe. So there's our pre-image. So a combination of 2 or more transformations. So we have 2 transformations here. We have this original SR, and it slid or over here to S prime, R prime, and then it slid again over here to S double prime, R double prime line segment. So any combination of 2 or more transformations to form a single transformation. All right. We also have a reflection, which is a transformation that uses a line like a mirror to reflect a figure. So we also have something that's going to help us with the line of reflection. Okay, so these kind of go together. So a reflection transformation that uses a line like a mirror to reflect a figure, and a line of reflection is a line that acts as a mirror for a reflection. So if we take a look at this image here of the CU Buffalo logo, we are reflecting it over this line of reflection. So this right here, this is my line of reflection because our our image, all right, is using it like a mirror. Our image here has been reflected over here, all right, and it's like a mirror. One thing is on the same side as the other, okay? So they are flipped over there. All right, we are going to give you extra credit if you're listening to this right now. So in your notes, let's see, let's put it right over here in this area right here where this line of reflection is. Put the words "Go Buffs." Okay, if you write "Go Buffs" right there, I'll give you some extra credit, and I think the other teachers will do that as well. But so we're going to do that right there. Okay, moving on. We have something called a glide reflection. And a glide reflection is a transformation involving a translation followed by a reflection. So, transformation involving a translation followed by a reflection. So we've got this heart. Here's our pre-image. We'll just call this pre-image since we have some uh, curves here. We'll just name this whole image an H, and we'll have it a slide over here, translates over to H prime, all right, along our vector. So it's going to go from here. It's going to go along our vector, same distance, same direction, into H prime, followed by a reflection. So this orange line is my line of reflection. This heart was flipped upside down to H double prime. It's a glide reflection. It glides and then it reflects. And finally, we're going to finish up with a line of symmetry. A line of symmetry. That is a line that maps a figure onto itself. All right, so this line that we see is a line of symmetry right here. So what that means is if it's going up and down right here, this line of symmetry, if I were to reflect this or flip this, going left or right across the line of symmetry, notice that nothing happens. It looks like it's the same image. Left and right, I can do it as many times as I want. Flipping it left and right, it's the same image. All right. However, if we do this as a line of symmetry and flip it up and down, let's see if that works. It does not. Notice how those are not the same shape. They're not flipping it or mapping it onto itself. Okay, so the line that is horizontal is actually not a line of symmetry because we can't do that. So a line of symmetry is a reflection that maps it onto itself. When it's reflected, it has to go right back onto the exact pre-image of what it looked like. All right, that is all we have for chapter 4, the first part. And we'll see you next time.